Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, I chat with Vaibhav Chellani, a bridge builder and the co-founder of Socket. We explore what makes up the components of a bridge, the types of bridges, and then look at a framework that they've developed to analyze the trade-offs around security in bridges. This episode comes at a really good time, since at the moment there are more and more bridges emerging to connect all these different chains together, and since they're so new, there are also a number of bugs, hacks, and exploits happening at the same time. Hopefully this gives you some insight into what's going on with bridges. Before we start in, though, I want to highlight a new video series we've launched this summer. It's called the ZK Whiteboard Sessions. It's produced by ZK Hack, as well as the ZK crew from Polygon. In it, hosts Bobbin and Brendan interview the top experts in the ZK space and explore the most important concepts and building blocks in zero knowledge. So, whereas this podcast is very conversational and quite broad in terms of topics, the ZK Whiteboard Sessions is educational and very much focused in on zero knowledge. It's also on video, so it allows you to explore the math in a much deeper way. If you want to learn more about zero-knowledge tech, this would be a great place to start. We already have a number of videos published, so be sure to check it out. I'll add the link in the show notes. One more thing, the ZK Summit returns for its 8th edition. This time we're going back to Berlin, and it's happening on September 15th. Be sure to apply to attend. And now Tanya will share a little bit about this week's sponsor.
Today's episode is sponsored by Manta Network. Manta is a privacy hub for Web3. By leveraging zero-knowledge proofs, Manta brings on-chain privacy to any crypto asset. Manta Pay, which is their first app, allows users to privately swap crypto assets cross-chain. Manta is also hiring. They're looking for skilled developers and engineers passionate about cryptography and passionate about bringing privacy protection services to all of Web3. Manta is remote first, backed by teams like Polychain, Binance, and other industry leaders. Check out careers.manta.network to apply. So thanks again, Manta. Now here's Anna's episode with Vaibhav Chellani.
Today, I'm here with Vaibhav Chellani, a bridge builder and the co-founder of Socket. Welcome to the show, Vaibhav.
Thank you so much, Anna. It's always been a dream to come here. Yeah, I've been a follower of the podcast for the last 2 years. Really excited to speak with you today, for sure.
Cool. Well, I welcome then as a guest this time around. You're on the other side. So today, I think what I really want to chat about is bridges. Mm-hmm. I was introduced to you by Kobe, our sometimes co-host here, and he had told me, I've been doing sort of an informal interview series with various bridge projects, and I've been doing this over the last year, or last 6 months at least. And yeah, he introduced me to you because he said that it might be cool to get sort of a meta perspective on the bridge landscape and that you would be someone who could help. I feel like it's super, super relevant right now. Obviously, we're kind of speaking in the midst of a number of like high profile, high value bridge hacks happening, or I guess you can call them hacks or vulnerabilities or bug exploits or something. But yeah, there's just a lot of interest and money flowing into bridge protocols, but also a lot of these kind of, like earth-shattering vulnerability or like these hacks that scare people away from it. And there's kind of this push and pull around the concept of bridges. But yeah, I think to start off, why don't we find out a little bit about you? Like, what is your road to bridges? What led you to this?
That's a fairly interesting story. Yeah, let me kind of start off from the very beginning. I was still in college when I joined as one of the first hires at Polygon, which was back in the day called Matic.
Yeah.
I was doing a bunch of Plasma research. Plasma Group was recently formed. Plasma was the way Ethereum would scale going forward. Like Vitalik was, very behind it. Like the whole group, it was super fun. We were having like YouTube sessions, community calls, whatever you may want to call it. That was super fun. We did like Plasma Prime, we did Plasma Debit, we did like about 360 flavors of Plasma. But unfortunately, like none of that worked out. So I was pretty bummed because of this. But internally, like Polygon decided to build a POS system, which I also heavily contributed to. And it was a fairly new tech at that point because Tezos was the only kind of POS system in production. And Tendermint, Cosmos, these were still, kind of trying to build these systems. So this was fairly interesting, but I still wanted to build a scaling system that inherits the properties of Ethereum like Plasma wanted to. And clearly, like the POS system was not that. So one fine evening, I noticed anonymous guy post a proposal on ETH Research, Barry Whitehat, that, hey guys, we should probably try to scale Ethereum via ZKPs. And I was like, okay, let's check this one out. Maybe it's just like another version of Plasma. But as it did turn out, towards the end, I was fully convinced, okay, this might as well work. It's very new tech, but looks really, really promising.
That was the origin of the ZK rollup concept, right? That was what he had sort of proposed. Did he call it a ZK rollup off the bat, or was it just sort of like, let's scale with ZK?
I think it was more of, like you mentioned, like, scaling Ethereum to 500 TXs.
Okay.
Something like that. That was the exact title. I got pretty excited. I texted him on Twitter. As generous he is, he kind of agreed to kind of form like a working group to start working on an implementation. Little did this was like one of the first implementations of ZK rollups in its entirety.
Cool.
And for me, like I did not understand anything about ZKPs, right? So Barry, pretty much handholded, kind of black boxed it really nicely, introduced me to things like Circom, Socrates, which were these like domain-specific languages for writing ZKP circuits. So I got really deep into that back in 2019, and I built a rollup. I presented that system during DEF CON Osaka. I gave a tutorial around like how to build a ZKP, and that was how I got extremely excited about rollups.
But rollups is, and this is a question I have for later, is like, what is a rollup? What is a bridge here? But now, would you say, was there a transformation from rollups to more bridge and like kind of cross-chain bridging?
Oh yeah, like what happened was like after I, kind of built a ZK rollup, I wanted to kind of do that full time, right?
Okay.
So I joined Ethereum Foundation, officially joined Barry's team,
Cool.
And we built out Hubble. Hubble is this like fastest optimistic rollup. And during that 1 year of like building this out, Hubble is now being used by the team at WorldCoin, which is this orb thing that scans eyeballs. All the good stuff. But that was like a super fun project. But a unique insight that I had during that project was, okay, while rollups are good, the actual problem is like state sharding. What that means is like if you took all the transactions on Ethereum and started doing those on a rollup, we would not have any scaling at all. So this meant we would need multiple rollups to kind of scale Ethereum. And that meant we need a system that allows inter-rollup communication. I just wanted to accelerate this journey towards asynchronous communication happening between different rollups because I see the future as like multiple rollups, paired to Ethereum, paired to Celestia, paired to other ecosystems.
Maybe I can ask the question now, is a rollup a bridge? Does a rollup have a bridge? Is it just a bridge? What is it?
It's a fairly interesting question, to be honest. Like, I don't know yet on how to actually term it. We recently kind of created a framework to evaluate bridges in collaboration with L2Beat. And if you go on that proposal, this is like the topic that we are debating about. Is rollup a bridge? If yes, what kind of a bridge? Like everyone agrees it's a bridge, but it's a pretty different kind of a bridge where it's so closely tied to Ethereum that social consensus of L1 also affects L2, right? So it's a very unique kind of and very closely attached to Ethereum kind of a bridge, I would say.
Got it. So what leads you to the work you do today? Actually, what is the work you do today?
So Socket is essentially an interop protocol which tries to allow developers to kind of send data and assets across chains.
Cool.
So part of our protocol is out there on mainnet today. The asset bridging part, it allows people to send assets from one chain to the next. The way we do that is we aggregate all third-party bridges, but we only do like native assets, right? So like native assets on one chain for native assets on another chain. So excited to kind of get into that also later during the podcast.
Cool, yeah. So let's kind of go into bridges. As mentioned, I've had a number of teams on who've talked about their particular bridge constructions, but I kind of want to explore this framework you just mentioned. But let's start sort of at the highest level. You sort of mentioned a rollup could be a form of bridge, but why don't we just say even above that, what is a bridge?
Yeah, what is a bridge? I think the definition has changed quite a bit over the last year specifically. For this event, I would kind of term a bridge as something that sends assets across chains.
Okay.
I would also introduce another interop system called messaging protocols. And I would place things like there are two chains always connected by a messaging protocol, and a bridge is an application on top of this messaging protocol. So a token bridge is a bridge that allows you to send tokens across chains. An NFT bridge would be an application on top of this messaging protocol that allows you to send NFTs across chains. We can imagine a governance bridge that allows you to vote from different chains. So I would kind of term bridges as applications built on top of a messaging protocol generally.
Would you say that, I mean, we can talk maybe about some of the different techniques that people are looking at when it comes to bridges. Do they live primarily on one chain? Are they a collection of smart contracts on two chains potentially, or are they their own entity?
Usually it's like a collection of smart contracts on two chains orchestrated by an off-chain actor that kind of becomes the man in the middle. How much do you trust this man in the middle? How much of the trust in the system relies with the man in the middle? That essentially describes bridge security.
And I guess going back to that question about what is a rollup a bridge, in that case, it usually only has connection to one chain, right? It's not necessarily between two different chains, but rather one. And then the question is the little link between the rollup and the main chain, is that a bridge? And that would also just be some contracts, right?
Oh, yeah. Like if I talk about like on an implementation level, almost all the rollups operate on a basis of like, let's have a get node running and have this component bridge, like our bridge optimism as the optimism messenger that connects the get node, the sequencer would be running to an L1 smart contract. So it's essentially also like, two chains connected by an extremely secure bridge. Patrick calls rollups as validating bridges. I think that's a pretty nice term. Yeah.
Interesting. Is it possible basically to construct a rollup where it doesn't have its own chain? It's literally just within the smart contract itself, that some logic is in there? It's almost like a dApp. Is that possible?
Yeah, that's why like these rollup systems are essentially just smart contracts. Smart contracts with a guy who's like, hey, just give me your transactions, I'll batch it and send it to L1. That's all the rollup operator or the sequencer does. Right. But then, to kind of elevate some liveliness concerns and things like that, people add some consensus mechanism to make sure if like the sequencer goes down, the transactions still keep processing. And that's how this like very simple model becomes like a chain that's connected to an L1. Right. But at the very core, it's a rollup. It's just a smart contract on L1. That's it.
Cool. I know that there was this comment by Vitalik, I think of 4 or 5 months ago. There's a blog post where he argued for a multi-chain future, but not a cross-chain future. So in this case, he's using the term multi-chain, I think, to refer to more like a roll-up-centric model with one data availability solution at the center, Ethereum. I don't know if he mentioned Celestia, but like it could also be something like that. Or like Polygon's Avail solution. But so that's a multi-chain in that definition. And he's kind of arguing against a cross-chain. And I'm curious a little bit like what you guys think about it. I know you also had a rebuttal blog post, so you might have some ideas.
Yeah, it was not exactly like a rebuttal. It was more like, I think, some nuances get missed. And like the comment that Vitalik posted was very interesting, given like no one had actually talked about that in that tone or like with that perspective before. And we are starting to see some similar discussions happen with ETH2 over the crypto Twitter over the last couple of days, where people have mentioned concerns that there will be like a ETH1 proof of work chain still running. Some miners would still run it. And what happens then? What happens to people providing liquidity on Uniswap, things like that. But yeah, it's getting like fairly hairy. So let me kind of address the comment directly first, and then we can get into like how it's similar to the current situation. So yeah, like the comment was generally, okay, you cannot really move assets from one chain to the next because blockchains have this unique property of social consensus that makes sure the blockchain is secure, right? What that means is like even if 51% of the participants in the network somehow collude, your funds are still safe because you can perform a hard fork. You can socially agree that some form of like collusion happened, and you can start a fork before the attack or the wrongdoings, started to happen. And that's what essentially makes a blockchain secure. Mm-hmm. But once you start bridging out of it, things start becoming hairy, right? Because what if the bridge accepts a deposit from a fork that's non-existent after a while because the chain socially hard forked to something else?
Yeah. We've talked about this a little bit on the show. There's this idea of like a fragmentation of liquidity. And I just picture trying to track that back across multiple, you just don't know what actions have happened with that. And so this idea that you could hard fork that, maybe it's possible, it just seems more and more complicated if you're also dealing with these like sort of third-party bridging protocols in the middle. Yeah, or if maybe even if like the origin contract gets messed up on the main chain, like how quickly does that proliferate through it and what effects does it have? It just becomes very crazy. But at the same time, I mean, I think the argument is like he prefers a multi-chain to cross-chain, but like it's not reality that we live in today. Whatever, 4 or 5 months after this blog post comes out, maybe even then, there's so much cross kind of chain liquidity happening.
I mean, the attack that he mentions is also like an extreme case, a chain getting 51% attacked. That has not happened very frequently in the history of blockchains. Mm-hmm. So it's a fairly extreme state. And I think we are already kind of using a lot of bridges. I see Circle as a bridge between a bank in US and on Ethereum, on Solana, on Polygon, and things like that.
Why do you see that as a bridge? That's actually, I'm curious, like it's not the bridge between the bank and these chains. Is it because it's the same underlying asset and they live on different chains so they could be interchangeable somehow? Or what do you mean?
Let me kind of start off with, let's say, Binance, right? So how Binance and Coinbase work is you transfer money to Binance on an address that they give you, let's say on Ethereum, and Binance kind of waits for, let's say, 12 confirmations, and then starts showing that asset as received on Binance, and it allows you to trade, right? Now, what happens if this was lost in a new social hard fork created by Ethereum? Binance just allowed a user to place a trade on an asset and book a profit when they did not receive money from him on Ethereum, right? Now, if you just replace Binance with Solana or Polygon, that essentially becomes the bridging infrastructure that we have right now. And that's exactly like the attack vector Vitalik's trying to point at. In the USDC example, right? Firstly, it's definitely not very close to like the bridging infrastructure that we have right now, given it's like it's more of an oracle because it's trying to like kind of map a physical entity to a digital one. But in some sense, it's accepting deposits or withdrawals from Ethereum back to the bank as well, right? So it also has to wait for finality on Ethereum, and it also has the same attack vector that Vitalik mentioned about bridges, right? What if a user kind of comes to Circle, says, hey, I want to withdraw my USDC, and Circle accepts that after 12 confirmations, right? And then the deposit is lost in a new social hard fork, right?
Okay.
So it's kind of the same attack vector, I would say.
You sort of just mentioned that it was like an oracle. I've actually heard that, I think in the interview we did with Nomad, they also mentioned that bridges are like oracles. Can you explain how that is?
Yeah, so it is quite interesting. Bridges are essentially like oracles, kind of trying to define oracles here. Oracles are things that let a blockchain know that something happened in the physical world. That's the definition that we have for oracles right now. Let's say there's a weather oracle. It will tell an on-chain smart contract that, hey, weather in California today is this much, right? That's an oracle. Now,
and maybe the most common example that we see are price oracles. So it's often like determining a price pairing, like what do they compare this token to this token at this time?
Exactly. So this oracle is trying to, let's say relay some information from Binance to Ethereum mainnet here, right? As I did before, let's just replace Binance with something like Solana or Polygon. It essentially now becomes a bridge, right? Because this oracle can also go to Ethereum and can tell that they just received a deposit from a user on Polygon. So oracles can become a bridge, but I like to kind of highlight a nuance here. I think oracles that kind of feed real world data to Ethereum mainnet are very hard to trust. And there are essentially no way to kind of do it without trust. And that's why Chainlink is pretty popular in that kind of scenario, because it's like really hard to map like physical entities and digital entities together, because it's just like such a different realm. But I feel we could do a lot better in the digital ecosystem, because when we are connecting two different blockchains, these are two digital entities that we are trying to connect. And there are ways to kind of prove to one entity that something happened on another entity. And we have to strive to not trust an oracle here. That would be like the worst case scenario if you're not able to figure out this billing situation. Of course, we can, kind of start trusting Chainlink again. But the fact that both of these chains operate on chain, they are digital in nature, and they have a way, some kind of cryptoeconomic security or other methods, I think we should be able to do better than like providing oracle level security in bridging.
Sort of speaking on this topic, seems kind of related. Another point that was brought up, I think on the Nomad episode, was this idea of almost like the call answer problem, where it's like, unlike a web call, you're sort of expecting something to bounce back. When it comes to blockchains, like they don't talk to each other that way. And the bridge, in a way, is trying to get like state of both so that it can act as this conversation piece between the two blockchains. Kind of going back to what you just said about the oracle, like in the case of them, thinking of them like an oracle, are they also acting a little bit like that communication layer in between?
Yeah, I mean, oracle is trying to like map a physical and digital entity. It might as well replace that physical entity with the digital entity, and that would be like the worst kind of bridge that we can have. Okay. And I basically define as like oracles being the lowest security possible, and everything else on top of that. Can only go better. Okay. It can only become better, and we can use like some sort of proof, some sort of cryptoeconomic guarantees, some ZKPs, hopefully, to kind of make this system trustless or trust minimize and not as trustful as oracles. And then you can do all sort of messaging, all sort of communication between two different chains.
Can you actually go a little deeper on that problem though, this call answer thing? Like what happens when something happens on one chain? Like basically, how do you get message and reaction? How does that even work?
I'm not 100% sure about what the context was when maybe James told this, but I'll try my best.
Okay, sorry. I'm referencing, maybe you haven't heard it.
All good. Basically, maybe the problem that he's trying to refer to is that, normal systems like Web2 is built in a pretty async fashion, right? Everything is async in Web2. Like making an API call is how you do composability between systems in Web2. In Web3, it's been synchronous communication so far. Right?
It is synchronous. It always has to happen at the same time. Okay.
Exactly. In the same transaction. Yeah. That's been the programming paradigm so far. Right. But over the last 2 years, we just realized that to scale a public blockchain, we have to break it down, and there will be some asynchronous system. We have to sacrifice some synchronicity to get scaling. And no one really knows like what's the best way to do async communication in a blockchain context. And bridges are an attempt to figuring that out. And Socket is an attempt to kind of actively push towards that, let's figure this problem out, because that's the only way we can scale Ethereum and other chains.
That's interesting. That idea of this right now, everything being synchronous, do you feel like the bridge solutions that exist today are actually making it asynchronous, or is it more just like we're making tiny baby steps towards having a more asynchronous system?
Kind of like going down the same analogy of like, Web 2 operating, fully asynchronous. If I were to kind of like 1:1 map it to the current bridging infrastructure, the API call in the Web 2 world takes 60 seconds at most. At 60 seconds, the communication stops no matter what, right?
Yeah. Either it's worked or it just gets canceled.
Exactly. And it's fairly cheap. Depending on like what kind of data you're trying to request, it's fairly cheap. But if I were to like 1:1 map this like Web 2 system that we have right now to Web 3, it would mean one API call costs like $100, $200 at the minimum. And the latency that you can expect is like 60 minutes or even a lot more, like 7 days in case of rollups, right? So we are definitely like taking baby steps towards it. Kind of hard to provide any sort of like guarantees in terms of like latency, because, no one really knows if a bridge kind of promises that, hey man, I'll bridge your transaction in like 5 minutes. So no one knows what the gas price is going to be, right? So it's like extremely hard to provide these guarantees, and the API calls are extremely expensive, extremely slow. So the amount of asynchronous communication that's happening right now is super small. It's mostly tokens, where you send a token from one chain and you receive it like whatever, 30 minutes later. But we will, kind of get there slowly, I guess.
Well, thank you for answering all these sort of like random questions. These are leftover bridge questions that I feel like I've accumulated over the last few months of doing these interviews. But let's talk more about this framework. I think that's what we wanted to really cover in this show, which is like the way of thinking about different bridges. Maybe it touches on some of the things we've already mentioned. I know that there's other concepts like light clients and even the sort of optimistic style that Nomad has, or the cryptographic style that Axelar has. So I'm just curious, like let's go into it. Let's start to dig into this framework.
Okay. Just to kind of like have some context about like why we started looking into this stuff. Socket's liquidity layer is essentially built like a aggregator of like third-party asset bridges. And we were like, okay, there are like all of these bridging solutions out there that are always trustless, of course. They're marketed, pretty heavily to like normal people, and this tech is generally hard to understand. So people use it and then they get wrecked, right? So us as a aggregator, probably bad timing, but we just felt it was important for us to provide some transparency on the security properties of the bridges that we are trying to integrate, right? So we had this list of like 150 different bridges, and we were trying to find ways to provide some information about how secure a particular bridge is without it being too researchy for a normal person to understand.
Wow. So 150 bridges. Is this sort of like bridge instances or bridge projects? Because I'm just thinking, like, would you count one of these bridges as like, if you have Solana to ETH, and then another bridge would be like, even if it's from the same company, like ETH to, I don't know, something else, Algorand.
No, these are actual projects. Like, these are actual bridging projects that are on mainnet. They have like small amount of liquidity, things like that.
Okay. So this is not each individual connection. These are projects.
Yeah.
And would you say that like in that 150, do you see very, very clear classifications of these approaches?
Yeah, not very clear classification. That's essentially why we had to kind of like do it in like a more community oriented way. We could not find a common framework that's very clear. A lot of bridges kind of lie in two buckets. A lot of bridges like do one thing differently that could change the whole dynamics of the system.
Wow. And the security, I guess.
Exactly.
Wow. Okay.
So we wanted to kind of do this more holistically, kind of chat with a bunch of teams on like how to exactly categorize these systems, because these are like so different. And for us, we just wanted to try and create a kind of score that we could assign. It would definitely not be super accurate, but that's what like we felt that people actually wanted. They don't want to kind of dive into details about like how this bridge works, things like that. To understand when they're trying to bridge assets, we just want to tell them, okay, this bridge is like 3 out of 5. This bridge is 3.5 out of 5. Just so that they have this upfront and it's not hidden behind like layers of marketing.
How did you do that score though yourself? Like, did you score certain kinds of bridges higher? Like say a like client bridge, would you just like, if there's a like client on either side, is that more secure in your book?
Definitely.
Okay.
Definitely. Like the like client bridges are definitely like the most secure ones after rollups, because rollups are like clients with social consensus. Like clients have the same like problem that we talked about Vitalik mentioning earlier. So like clients with social consensus, that's rollups. Like clients with validity proofs, that's something like what Mina is trying to do. And then there are like normal like clients. But yeah, this is probably like a good time to like get into all of this like classification detail.
Sure. Yeah, let's do it.
Okay, sweet. So like starting from the very beginning, we talked about this a little bit earlier, but I'm talking about bridges as an application on top of a messaging protocol. So if the messaging protocol has a security property, all applications on top of it inherit that security property directly. Just to give an example, let's talk about Ethereum and Optimism. Optimism has an Optimism messaging bridge of sorts, and any token bridge that's built on top inherits the same rollup security, right? What that means is, going from Ethereum to Optimism would be super fast. Going from Optimism back to Ethereum would be super slow, like 7 days or things like that.
Just one thing, when you talk about like the token, you're using this term for like what's built on top. What did you say again? The token bridging? I
call it token bridge.
The token bridge. So the token bridge itself, like I think of Optimism as sort of a bridging, like it would provide you with the application to actually do the bridging. But are you saying that like any app developer could basically make their own interface and it would be kind of living on both sides, but using this bridge? And that would always have the same properties of the underlying message passing protocol. I think, is that how you say it? Yeah, I got to get this language right.
I mean, no one really kind of has defined these terms, so we are free to use whatever we want.
Okay, cool.
Yeah, so like Optimism essentially has provided a way to securely send data from Ethereum to Optimism and vice versa. Now, this data can be anything. It can be a data about like bridging of a token, bridging of an NFT, and applications, like people can come and kind of build bridge applications on top of this messaging protocol that they have built. So Optimism Token Bridge is just one example that Optimism team has built. So Synthetics, for example, uses the same messaging system, but they have a different kind of like bridging mechanism that's not the same as Optimism Token Bridge.
Okay.
So yeah, people can come and experiment as they like, build like different sort of like logic on top. Things like, I'm on L2, I want to vote on a proposal that's on L1. Yes, you can do that via Optimism messaging bridge, right? You just have to build an application on top. Yeah. So the hierarchy is a messaging bridge. I just call it a messaging protocol, just to not use like bridges very frequently. So a messaging protocol, bridge applications on top, and then comes this new term called liquidity networks on top of token bridges, right? So token bridge is something that allows you to send tokens from one chain to the next. Liquidity networks are systems that allow you to swap these tokens from one chain to the next. So when you use a liquidity network, you basically swap out an already minted asset and not kind of mint a new one, right? This difference is like pretty subtle, pretty confusing at times. So happy to kind of dive a little bit deeper.
I want to go over those steps again because I started writing them down as you were saying them, but it's messaging bridge, message protocol, token bridge.
I would just call it a messaging protocol, a token bridge on top, then a liquidity network. You can kind of remove the bottom layer.
The bottom layer. Okay.
Yeah.
But the liquidity network, is that sort of like a DEX? Is that like when you're trading, like instead of it being that you're going, like if you wanted to trade a dot for ETH, could you just in this other sphere, just like do it automatically kind of immediately without having to transfer and wrap your assets to each one? Is that sort of what you mean when you say liquidity network?
Yeah, that is kind of close. So essentially, let's say USDC on Ethereum is not the same as USDC on Solana.
Okay.
Right? So these are different assets. So you can kind of imagine liquidity networks as being a cross-chain DEX such that they allow you to swap USDC on Solana for USDC on Ethereum because these are different assets.
Okay.
Altogether.
But it doesn't allow you to swap. It's not allowing you to do full cross-network trades. Or
No.
could it?
No, it's not allowing you to no token actually crosses Ethereum
Yeah.
and Solana boundaries. It's just that you exchange ownerships with the counterparty.
Okay.
So the guy who's holding USDC Solana, you take the USDC Solana from him in exchange for taking the Ethereum Solana, from the other guy. So it's like kind of changing ownership on both sides, but no actual asset movement happened between the boundaries.
But do they have to be the same asset synthetically on each side? The example you gave is USDC on two chains, but could it be two different tokens on two different chains?
Yeah, it definitely could be. Yeah. Okay. Well, USDC here, it's technically the same asset, but it's on Solana and Ethereum, so it's actually different assets.
I guess I'm thinking almost like from a trader's perspective where like maybe just a simple trader's perspective where you'd really just you have it sitting somewhere, you want sort of maybe the native token on the other chain. And I'm wondering if this liquidity network would be something that could happen. What about stuff like loans and could you also use a liquidity network to do more sophisticated DeFi stuff? Like potentially locking tokens on one side to provide as collateral and then providing liquidity on another?
I mean, there are some tricky ways to do it, but at that point you might want to use the token bridge or the messaging protocol to do it, right? Because you could just build this whole thing as a application on top of the messaging protocol, that would make it a lot more simpler because these liquidity networks are a lot of time kind of restricted by the amount of liquidity. So you likely will not want to be restrained by that.
Can we go a little deeper into liquidity network then? Because I don't know if I fully see the distinction there.
Of course. Let me maybe start off with some examples, right? So an example of a liquidity network in production right now are things like Hop and Connect, right? So Hop and Connect, they allow you to get into an engagement with the counterparty or with the market maker who swaps the token with you for a fees, right? And that's the reason why these things can be super fast, super cheap, things like that, right? To kind of elaborate on the difference between a token bridge and a liquidity network, maybe let me kind of walk through the journey in both cases. So let's say you want to move some money from Polygon to Ethereum, right? Let's do Ethereum to Polygon. Let's say you want to move 100 USDC from Ethereum to Polygon. You go to the token bridge. The token bridge escrows the money on a smart contract on Ethereum, and the Polygon native bridge mints a wrapped version of USDC on Polygon. And now applications use this wrapped version of USDC as normal USDC, and it's like the native USDC until Circle starts minting there.
Okay, and until it goes direct, until Circle goes direct. Okay.
Yeah. So assuming Circle is not minting directly on Polygon, this is essentially Polygon USDC, right? Okay. So now a user, when he's trying to kind of, bridge from Ethereum to Polygon, he has this one way of doing it, which is going via the Polygon native bridge that would mint new USDC and escrow his USDC on Ethereum.
Yeah.
The other way that we're talking about, which is the liquidity networks, what happens there is you are on Ethereum. You look for guys who are willing to give you 100 or let's say 99 USDC on Polygon. Once you find this guy, you lock your money inside a smart contract on Ethereum. This market maker or this counterparty, he gives you money on Polygon. So you receive 99 USDC on Polygon. And then this guy can go back on Ethereum and take your 100 USDC there.
I see. So you don't mint it. You just use existing on one side. That actually speaks to a very old episode we did about like the lock, unlock, mint, burn kind of concept. So what you described with the token bridge there is that you would basically lock on one side and then mint on the other. And then I guess to move backwards, you have to burn it. And then you'd unlock it on the main, on that original space. Here, what you're talking about is like lock, unlock on one side and lock, unlock on the other, right? Or just like trade to you. It's like you get it.
Yeah, it's more like a swap, you know?
Okay.
So it's like a token swap. There is no token transfer. There's just like swapping of tokens that's happening across chains. Just to kind of highlight a very interesting difference here is that usually these liquidity networks can be pretty fast because you are essentially kind of engaging with a market maker, right? So let's say I'm trying to move from Ethereum to Polygon and you are kind of offering me a rate, let's say, 98 USDC, right? So you might be willing to take on some kind of rollback risk in exchange for more fees, right? What that means is you would allow me to get from Ethereum to Polygon in, let's say, 2 minutes instead of Polygon native bridge doing it in 15, 20 minutes.
Yeah.
Because you can offer more competitive rates because you can take on additional risk for a fees, right?
Okay.
So usually people use these liquidity networks for like faster transfers and, kind of bypass the native bridge. And if you notice clearly, this concept started coming up. Like a lot of these kind of bridging designs started to come up when Arbitrum and Optimism went live. Because using the native bridge there for going from Optimism back to Ethereum is not really an option.
Because it takes 7 days or so.
Yeah. So we needed like a swap protocol that would give it to you instantly.
Got it. Behind the scenes, though, are they manually using those bridges as well? Like, are they moving those tokens over sort of, and then in the meantime, lending stuff out to you or like giving you things? Is that sort of how it works?
Yeah, definitely. So these guys would be maintaining like liquidity pools on both chains, and they would be like kind of swapping between these liquidity pools. But you have to imagine at some point, one of their pools will not have liquidity anymore. So at that point, they would rebalance, and they would rebalance via whatever messaging bridge or token bridge that's connecting these two chains. So at some point, they would be using it, but it would be in a more batched fashion, right? And only when they've run out of liquidity.
Got it. So you've just kind of given that description of how these bridges are built and these different components of like a bridge or I don't even know how to describe it because it's like multiple bridges, protocols, whatever. Basically like how these cross-chain entities are starting to develop and the stack that they have. But I kind of want to go back to the framework and the security. And actually, I want to step back because you had started to tell us the most secure, and you were kind of going down. And I'm curious what happens after. Where did you stop? You stopped at like client, but not validity proof. And then I don't know what happens after in terms of security.
Yeah, definitely. Let's get into that stuff. So maybe we can go in some sort of order, right? Order of security, right?
Yeah.
So we have kind of nailed down the stack here, a messaging protocol, on top of that, a token bridge, on top of that, a liquidity network, right? And now we'll start going into some like how are these bridges designed and how that affects security. And we'll do that in a decreasing order. We'll start with the most effective way to move assets or data across chains, and that would be what rollups do, right?
Okay.
So in the framework itself, we call it like live client verifying validity of the state.
Okay.
Right. These are like the most secure way to do cross-chain bridging. We essentially kind of describe it as like bridges that verify the validity of a state transition that happened on the source chain, but we validate or verify it on the destination chain. So the destination chain will take all of those transactions, it will validate it somehow that these were correct, and only then kind of accept it. So let me kind of describe how rollups are an example of this, right? So when we are talking about, ZK rollups or optimistic rollups, let's assume these are two different chains connected by a bridge, right? So a ZK rollup essentially proves to Ethereum that, hey man, I just processed some transactions on my side, and here's the ZKP that attests or like that proves that all of these transactions were done correctly. And in the optimistic scenario, it's like, hey Ethereum, these are the transactions I processed.
Prove me wrong.
Prove me wrong. Yeah. It's like a very lazy way of doing it. But essentially, Ethereum is the source of truth. Ethereum kind of verifies all transactions and the validity of those transactions. So this is one kind, right? The more secure kind, we can get into other trade-offs, but talking about only security, this is the best that you can get.
Okay.
So now we go a little bit less, right? So the second thing that we introduced was like clients validating consensus. So these are systems that allow asset and data movements, but they only validate consensus.
Okay.
Right? So let's say you were trying to bridge between Ethereum and Solana. This is all theoretical. I don't think it's actually possible, but you would be verifying consensus of Solana on Ethereum and vice versa.
Okay.
You wouldn't be checking all transactions. You wouldn't be like, kind of seeing if the transactions were executed correctly. You would just be like, okay, if 2/3 of the validators say it's secure, then it's secure.
Cool.
Right? You don't have to get into the nitty-gritties. Just to elaborate the difference between both of these things, the earlier one, like client validating transactions, that's more like a full node in Ethereum's context. A light client validating consensus, it's more of a light client in Ethereum's context, like a light node that people can run in their browsers, right?
Cool.
And we obviously know, kind of running a full node is definitely more secure than running a light client, right? Mm-hmm. So it's kind of like borrowing some like similar properties there. A bunch of examples here. For the first one, it was like rollups. For the second one, it's like the Polygon POS bridge. Cosmos IBC is a great example. Like IBC, it's all light client based. You have two chains. They both validate consensus of each other. As long as they both are honest, things are extremely good.
It's interesting to me that you put Rollup as more secure than IBC. I guess I never really thought of that comparison. You also mentioned sort of like the Mina setting, but is that one layer down from IBC, where it's like it proves itself kind of, but it doesn't necessarily. It just submits a proof. It's not that has to live somewhere else. Just the proof is enough.
Yeah, you touched upon a very interesting point. This is like the exact point that we are fighting on right now over the L2Beat forum.
Okay.
So the Mina bridge is interesting because it's also validating transactions, but it's not as secure as rollups. So I would put it somewhere in between. I would put it somewhere between Cosmos IBC and Rollups.
Okay, so it's even higher in terms of security than IBC.
Definitely.
Okay.
Definitely. Because in Cosmos IBC, if one of these chains lie, that the validity of consensus, let's say, 2/3 validator collude, then the destination chain would gladly accept it.
Okay.
But here, the Mina chain is posting a ZKP. So if the ZKP is valid, the state transitions are valid, and the destination chain would accept it, and they have no problems with like consensus failures or things like that.
Cool.
The problem the Mina chain has that rollups don't is social consensus.
What does that mean?
Let's say you try to bridge out of Mina to Ethereum, and you created a valid ZKP for it. Ethereum gladly accepted it, but Mina hard forked.
Oh. Yes. Okay.
Something else.
Okay. This is that. Okay.
Yeah. Mina hard forked to something else, and it's gone now. It's like fully wrecked.
Okay.
Rollups don't have this problem because there is one source of truth. That's Ethereum L1.
Got it.
But in Mina and Ethereum, both are at the same level. I would put it like that.
And the idea is if Ethereum hard forked, which is hard to do and unlikely, but like say that happens, then it would carry with it all of its roll-up stuff anyway.
Yeah, exactly.
So it would kind of follow it. Okay, cool. So I get that. So then in the case going back to IBC though, and then IBC also doesn't have the social consensus part. It could also have one side of it hard fork, and it would kind of wreck a lot of transactions or like, assets being held on either chain. Okay.
Yeah, this is exactly why I think Cosmos trying to build Tendermint makes a lot of sense, because Tendermint has this really nice property of instant finality. What that means is like, as soon as a block is minted, you can be assured that it's final, that there would be no forks. And this is really good for bridging, because then you are not worried about like forks and things like that. So that's why like Tendermint makes a lot of sense.
Okay. Going down the stack. So
yeah, going down the stack.
Or not the stack. It's going through the list on the spectrum. Okay.
Yeah.
Where are we at?
So the next one is where most of the bridges lie right now. And that's external validator set, right?
Okay.
So far, we haven't seen anything adding security in the middle or like taking off security in the middle, right? It's been two chains trying to communicate with each other. And we've been like talking about different ways to do that. But with the external validator set, we kind of say that we'll add another chain in between.
Yes.
And both of us, we would trust this chain for cross-chain transactions, right? So all the security moves from trusting the execution on both of these chains to trusting the execution of this middle chain.
And I guess a good example here would be like Gravity Bridge and Axelar, and I think Swift Chain, Wormhole. But would you put Nomad in there? Because I spoke to them about it, and they said, I mean, they don't have a validator set. They have watchers. They have these other agents that sort of check it, but they're not exactly like a full chain in and of themselves.
Yeah, it's kind of like a nuanced take here. I mean, for the framework itself, we put optimistic validation in a separate bucket. Okay. But I would personally put the current Nomad system in an external validator bucket, mostly because the watcher set is kind of permissioned, meaning no one who does not have permission already. So it's not like an optimistic rollup where if the sequencer says, hey Ethereum, here's the latest state root, these are the transactions, and now anyone in the world can literally come and challenge. The current Nomad system is not like this. The current Nomad system only allows a subset or whitelisted actors to kind of pause the system, right? So it's kind of moving from the external validator set, where validators approve of transactions, to a model where validators pause.
I see.
So it's a good or a different kind of trade-off in the sense that things like Ronin hacks, where the private key got leaked, things like that cannot happen, because the worst thing that you can do is like pause the system. So it's like good in that sense.
Going further, are there even less secure types?
Definitely. So now that we've kind of introduced that, okay, we can have a chain in the middle that's like validating or that's providing security to everything cross-chain. Now we can just like talk about how secure this like middle chain is, right? The top level security, I mean, what we would call trustless in terms of like cross-chain would be if you don't add any security, then the two chains that you're trying to connect between, right? That's why like rollups are the best, right? So here we've introduced a full new like
third one,
trust entity. Yeah.
Okay.
And it's not like what people wanted to opt in. So now the security is like as secure as this third chain is, right?
Okay.
And now we are talking about how many validators does this third chain has? Who runs these validators? Is it the same entity? What's the stake distribution? Things like that, right? Things that we wouldn't be worried about if this was a L1, because again, social consensus.
Okay. More insecure.
more insecure. I think now it's about different parameters. I think broadly we've like covered all different techniques. Now it's about different parameters. Parameters like, who's the validator? How many are these?
Like a 5-person multisig as is not good. That's very dangerous. Would you actually consider these sort of multisigs as bridges? Like where it's purely there's no third party, there's no light client. It's just like, signers.
But yeah, these signers then become the third party, right?
Okay.
Yeah. So they are like yeah, this is like exactly how like 60-70% of bridging is done right now by multisigs, for sure.
Everything we've talked about here is security, but there are other trade-offs. Were there other metrics that you were also looking at in your evaluation of these bridges, or was it just security? Because there's time, there's like, how long does it take? How easy is it to build on top of? Maybe like, can people build on, like some of these might just be really complicated to actually build anything on.
Absolutely. So when we started building Socket's liquidity layer, we wanted to build like a system that allows people to send USDC from one chain to the next. That's the goal, right? Then we started looking at all of these different systems, and we found out we could black box asset bridges or like token bridges into three properties, right? One is security, one is latency, and the third one is cost. Okay. So if we have these three things, we can transparently tell the user what the bridge is, right?
Got it.
Give me a bridge and these three things, and I know everything about that bridge, right? So depending on like how the bridge is constructed, all these three things vary, right? So if it's a rollup and it's an optimistic rollup, the latency becomes 7 days.
Yeah.
Right. If it's
and the cost,
kind of remains. I would probably call it medium.
Okay.
But high if it's a ZKP,
Yeah.
And the prices change, right? Prices change because we also have liquidity networks, which are like Hop, Connect, Stargate, and these are just like market makers offering you a rate to go cross-chain, right? So it started looking a lot more like the DEX problem than the actual bridging problem. We started seeing asset bridging as more like we have 150 different options, and they all vary in like 3 dimensions: security, latency, and cost. And we want to offer the best one to the end user.
In your system, do users actually get to choose how secure, how expensive, how fast?
Exactly. They have like
interesting.
3 options, whatever they want to prioritize. If you're trying to bridge larger amounts, you would want to use the native chain, even native bridge, even if it takes a little bit longer or it costs a little bit more, because these liquidity networks might not have enough liquidity to even, kind of process that. So we started aggregating these. These are 3 properties we care about. We are trying to build out this like framework to kind of assess how to think about security with these systems. Cost and latency, those are like fairly objective and easier to think about. Latency, we just like kind of see how much time has this provider taken over the last like 2 months, and we kind of calculate a median. On the cost, it's like easy to see because everything is happening on chain.
I think this sort of leads us to like, what do you think is a good strategy for people who want to build on top of bridges or use them? Because we happen to be interviewing, I know this episode's going to come out a little later, but we're talking on the week that the Nomad exploit happened. And we have a lot of friends. I have a lot of friends there. I think you might have friends there too. And obviously we're feeling for the team and everything they're going through. But I also know some people who've lost funds. So what do you kind of recommend in terms of what strategy, like what do we do with this landscape? Because I don't think only relying on rollups actually works, right?
True.
There's delay, there's high cost, there's like other drawbacks that are going to make it so not everyone's just going to go for the most secure. So what do we do?
Yeah, I mean, we try to break this problem down into 2 things. One is asset bridging and one is data bridging again, right? If you're trying to do asset bridging and if you only do like native assets, then you are fine trusting a not so secure solution. The reason being, the most damage that this bridge can do is not give you money on the other side, right? So let's say if you wanted to bridge Aave from Ethereum to Polygon, for example, right? You can swap that Aave to USDC, bridge the USDC, and then swap back from USDC to Aave. That way, you don't actually have to do like Aave bridging. You can use USDC. And as soon as you swap your USDC to like the native Aave, you are done with the bridging risk, right? You are essentially out of the bridging system. So when it comes to asset bridging, I would like definitely suggest, kind of sticking to native assets and trying to be away from like, creating a new wrapped version of your assets. And if you do, try to add some kind of like gauges where you have things like 1% of my token supply can be maintained in 24 hours.
Okay.
So that you have like, some kind of like parameters or insurance that you can kind of play around with, and over time kind of increase these parameters instead of trusting them from day one. So I think a lot more of this infrastructure and a lot more of these techniques have to be adopted given where the landscape is right now. But yeah, I would just kind of suggest, okay, add more of these gauges, think more about what could happen when things go wrong, and try to add backstops for it.
Yeah.
Try to, kind of insure your users or things like that. There's not much. Yeah.
Do you think that we will find one bridge technique to win them all eventually? Or do you think we are going to have even more bridge techniques? Or do you think maybe they just sort of cluster around some like winning strategies?
Definitely cluster around, right? I personally think like rollups are the way to kind of scale Ethereum. It's like if your application is a rollup and it's kind of like tied to the same data availability layer, you have by definition better bridging than if this application was a chain and not a rollup. If it's a rollup, you can trustlessly communicate from your rollup system to another rollup systems trustlessly. But if you're an app chain, it's trustful bridging to everything else, right? So my personal feeling is like people will choose systems which offer some kind of shared security. That Ethereum provides this, Celestia plans to provide it, Polkadot provides it, Cosmos is trying to provide it with interchain security.
Yeah.
So these kind of systems kind of create this like cluster topology where communication within the cluster is very trust minimized, but communication outside the cluster is not that trust minimized.
So it's relying more on these bridge things and on sort of the bridge protocols.
Yeah.
Yeah, I think that's a world that I've sort of heard described a couple ways and times by different groups. And I think it does seem like a possible future. It's not what it is right now though, hey? Like right now it really does seem like interoperability solutions, bridging projects come out and they do bridge to like all the EVM chains, or they're sort of like that you see multiples of these. They might have some sort of, they're more featured in some networks versus others, but yeah, do you think there might be a move away from that model?
I mean, theoretically it should, but given like we are still pumping like so much money into like Aptos, Sui, Solana, things like that. There is a lot of incentive to go to Aptos, right? 10 years down the lane, maybe this happens, but there's a lot of money that's going around that is moving in the opposite direction. So I don't know for sure, but my bet is that we'll see some sort of clustering happen.
So I want to sort of round this out with a little bit more of a look into Socket, the project you're working on, and kind of, I'm curious, like, where are you at? What choices have you made after having done this analysis? Like, where do you live? Where do you plan on expanding to?
Yeah, so at this point, Socket's liquidity layer, it's been on mainnet for a while. I think we started like last December. And we also had this like philosophy of not adding more trust to the system. And we've like built out Socket with no upgradable contracts, with no proxies, with full immutability. We don't want to add any trust properties while aggregating these asset bridges. It should be like the user is trying to use this bridge directly, because it would make no sense if we, kind of add a multisig on top, and the user is kind of choosing a trustless bridge, because then it becomes a multisig bridge no matter how trustless it is. Like Socket's been live. I think it's doing like fairly well. We have an application of ourselves on top called Bungee Exchange. The goal of that application is to rethink bridging UX, because like bridging UX is fairly shitty right now, to be honest. Like funds leave your wallet on one chain and you pray to the god that they appear on the other chain. So it's just our like attempt at, trying to do what Uniswap did to swapping. We want to try and do the same for bridging. So this is like on the liquidity layer front. I think a bunch of people really use it. That our only goal there is to kind of allow the user to make an informed decision about what route is he choosing. A bunch of projects take a certain trade-off where they want to be more cheap, more fast than secure, and that's absolutely fine. But what's not fine is kind of hiding that behind marketing. So our goal is to kind of inform the user about the particular trade-off, and the user then may as well take it. It's a perfectly fine trade-off for an asset bridge.
Which ones do you live on already, though?
We are on 9 different chains right now, mostly EVM.
Okay.
But we might try out like Solana. We had plans for Terra, but that went away. I cannot hope the same for Solana, so we'll definitely do it at some point.
But do you live on top of existing message protocol, message bridges, or are you building your own?
So we are kind of building a data solution that allows people to send assets via the liquidity layer and then perform some action with it via our messaging layer, right? So let's say if you want to bridge your assets, deposit into Aave, right? The way you would do that is like send your assets via the liquidity layer, where the asset would be sent via, let's say, Hop, Connects, or like whoever the market maker is who's providing the best or the cheapest way to kind of send that asset across. Right?
Okay.
And once we have that asset on the other side, the data layer kind of informs on what to do with the asset now.
Okay.
Is it, does the user want it to be deposited into Aave? Does the user kind of, want to vote on governance? Things like that.
But you don't live across, you're not using IBC, you don't live across Nomad, you're not on top of XLR. You're not like using any of those existing ones. Okay.
No. I think our goal there is, try to provide similar to like our liquidity layer, try to provide all trade-offs to people and allow them to build systems that kind of go from external validator set to rollups by a simple change in a configuration. That's it. Right. Cool. And then we will obviously, using our risk framework, show that to the user in a very transparent manner. But the users or like projects should be okay taking a certain trade-off, and users should be informed about it. That's the only thing that we are going for here.
Cool. Well, thanks so much for coming on the show and sharing with us this sort of framework for thinking about bridges, and also giving us kind of a sense for what you're doing over at Socket.
Of course. Thank you so much for having me. This was definitely a fun conversation.
Totally. And I want to say a big thank you to the ZK podcast production team, Tanya, Henrik, and Rachel. And to our listeners, thanks for listening.